In this episode of Finno-Ugric Machining, it will be, some aluminium parts. We are going to make a slot into them, and then we are going to have some steel parts with one with a little bit threading, and another with also some sort of threading, but you will see. The ones that should be slot. Wait a minute. Well, here is one. And these pieces should be slotted on the top, and it's about 40 millimeters long, 42 actually, and then there should be 30 millimeters deep slot going this way. And there is a slight holding issue in this one. It's aluminium, and if I hold it in some sort of a chuck, only 10 millimeters from the end, it will not end up well. It will actually destroy the surface of this one. So I will first make a holder for this. So let's go on with that one first. Well, now I am going to level this side and also the side which is now there under. This is just to make it possible to hold it in vice jaws securely. And I'm running this about 400 revolutions per minute. Could be run faster, but I don't want. And the feed is, it's 17 millimeters per minute, so very slow actually. So here we go. Well, it's a little bit rough, and not just a little, but it's actually really rough. Now I debur it and turn it around. Let's wipe these away. So there is a horrific burr in both sides actually, but there is nothing that beats a file here. Let's see which side. Of course, the fine side. Well, that's one side. That's the other side. Now, yeah. Now we put it there back. Did we have a lot of trash in there? Yeah, of course we had. Well, it doesn't need to be really exact. And now I would like to touch it first. It can. Let's see now. Let's take the other side. I think this will clean up in one go. It already touched there. Oh yeah. So just a little bit that now. I think I should. Well, let's speed it up a little bit. Now it's 600 RPM. This should be a little bit better. Let's see. Well, actually the surface finish is not much better. But it's adequate for this operation, which is next step will be drilling a hole sideways this direction. And it will be, it should be quite accurate. It's the nominal size for those pieces was like 30 millimeters, but when I measured them, I noticed that these are 29.65, 68 millimeters, so they are almost 0.4 millimeters undersize. So I need to make this match them, not the 30 millimeters. So let me set this up for milling, really milling the hole. Well, okay, now I have deburred the sides, and now it's on the vise like this. And if you look carefully, you can see a crisscross there. Well, the place of that hole is not very relevant. It should be somewhere in the center, and it should be far enough away from that edge so that I can put a bolt in there. So it's actually 25 millimeters. The radius of this hole is 15, and then it leaves 10 more millimeters here. So that should be enough for an M6 bolt. So, well, it's better to be near enough that hole so that it really tightens it. And then we also will drill another hole here to bolt this thing into the milling machine table. It will be 10 millimeters. But let's do the alignment first. This is, well, just by sight. Let's see now. First the X direction here. I mean Y. I think it's there. Oh well, let's lock the answer here, and then man, it doesn't want to turn. Now it wants to turn. I want to look this drill from the sides of the flute so I can get it. Oh, well, let's say that that is our position. Yeah, I lock the table now here. But what I will do, I will actually, okay, let's do it so that we know which direction the backslash is. Okay. And then I also have, there is a scale here on the side. I want to have this on place so that I know where we are about. Okay, we lock our answer there, X and Y directions. So this is now a 5 millimeter drill. I will first make a pilot hole here. Well, it helps if you have the gear on. It usually helps drilling operations. 600 revolutions? Yeah, okay, this drill can do that. I'm feeding manually. Don't focus. I think we can do this right. Yeah, it's good. And now, since we know the place, I have all the dials here. So now, we need the 10 millimeter hole this way. So if we first take 15 millimeters and then, well, maybe 10. So 25 millimeters, and there we should have another hole. So 25 millimeters this direction. So I unlock the X and make the hole there. So 25. I think there is our 25. Yep. We will have here finally a 10 millimeter hole. Well, I noticed that it could probably benefit from cutting oil, so we will use it. Away we go. Another pilot hole. There you are. And now we change the drill to a 10 millimeter drill for that hole. It will be like, the bolts in my milling table are 10 millimeter bolts. Okay, and now of course this speed is way too much, so we need to slow it down. Well, wait a minute. Okay, this is okay. It's running 130 revolutions per minute. Well, I'll do it with this. It looks to be good. So, a little bit of fluid there, and I'm again feeding manually. Let's see how this goes. So this is the final size of this hole. Yeah, this works great. Where is it? Oh yeah, there. That's one hole, and then we go back to this the other hole. That's now the final size for that one, and then first this way, and then I come back so that my backslash is okay. There. There is the hole. And now we drill that one too, to 10 millimeters. It will become larger, but this is a correct step here. So yeah. Okay. There we go. Another 10 millimeter hole. Yep, that's ready now for 10 millimeters. Well, next will be a much larger drill. It will be, well, I think we could probably do the final size. Not the final size, but maybe 29 millimeter drill would do it. Let's see. I'll see what I can find. Well, now, this is a 25 millimeter twist drill. And this time I'm running it 90 revolutions per minute. Oh, well, and really hope that it's like sharp enough so it doesn't push my workpiece down, but cuts it. Well, let's see how it cuts. Now it will be seen. Okay. Uh-huh. 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 Okay. Now it's cutting. I have to progress this quite slowly. Yeah, it's quite sharp actually. And cutting with both flutes, which is really good. Okay, more choice. Here on the top of the drill it will go down by itself. Gravity assisted lubrication. So that shows me when it I put this one under there, so I know when the tip is through. Yeah, it's true. Okay. Now we have a hole in there. Well, next thing is the Wollhaupter. It will be used to, I will bore this to the correct size. It needs to be accurate. And well, therefore I have a 29 millimeter drill, but I didn't want to use it because I want to have some wiggle room, so to say, to calibrate my Wollhaupter, etc., so that I can get it to the correct dimension. So now I change over to Wollhaupter. Okay, I have now set up my boring head here, and well, I have touched the inside surface, and now I'm taking half a millimeter away from that. And this is now run well, 300 revolutions per minute, and I'm feeding the table up 17 millimeters per minute. So let's go. This should be a half millimeter cut. Well, you cannot blame for a bad surface about that. So now I will pull it here in order to be able to measure it. So let's see now. I'm using my snap gauges here. Oh man, okay. Yeah, okay. I think we got it. This should be near something like, oh well, 25.5, somewhere in that neighborhood. Well, it's not, it's 25.65, I believe. Okay, 25.65. And now let's go back to the correct place. Should be there, quite exactly. There. Yeah, okay. 0.65. Well, I will advance half a millimeter anyway. So, man, I cannot see anything with this. This I can. That's half a millimeter. And now, next. Yeah. There we go. Well, it's the same thing here as in lathe. The two last passes should be quite similar. So let's measure now what we got here and then see what we need to do with this one. Well, this tool is this stick is at the moment at the edge of its capacity. Should I? Okay. Oh yeah, no. No, no, that's not good. Okay, that should be good. I'll measure it now 2 times because I want to be sure here. So it is 29.40. The first measurement was that much. Let's take another. This is very, because well, the springs are not working well when they are. Oh man, this really is something. Okay, now. Another measurement. Let's see how much is it this time. I got 300 less. So I measure it 3rd time. Let's take it this way this time. Okay. Yeah, I got the same result now. That's probably our measure. From 38 to 68, how much is it? It's 0.3, isn't it? 0.1, 0.2 and 0.3. Should I make it hundreds of a millimeter large? Yes, I should actually, so that it's not too tight. Well, it can be widened, but yeah, that's okay now. Well, that's our final cut, and let's see how it goes. That's our Y. And now we go. Let's take the chips away from there. Not a lot of them this time. Yeah, wow. It's all the way up now. And now let's not measure, but I will try it out with the workpiece. Wow, the surface couldn't be any better. That's good news for the workpieces. Let's see now, this should fit in there quite perfectly. Yeah. This has some burr in it, so it doesn't want to go, but yeah, this will be good. Really good. Yeah. That's okay. Okay. Now, well, yeah. Okay, we are done with this. Well, now, this step is to mill a recess here. There will be a bolt. So this is just to avoid drilling like all the way through. I can make it the hole a little bit shorter this way. So well, it is 12 millimeters that way, and then I will go 6 millimeters deep, maybe 10. Well, let's see how this goes. So first, I'm a little bit conservative here. I only take 1.5 millimeters, and this needs to be fed by hand. Now it's 6 millimeters. Should I take it a little bit more? Oh man, a burr. Now it's 6. Maybe 9 millimeters. So 3 more, it would be there. Actually, okay. Let's take 3 more millimeters from that. And then the same thing for the other side. Now the next step is to drill a 6.5 millimeter hole to there. This is the, well, there will be a 6 millimeter bolt and a nut. I would thread this one, but I'll put a nut in there. It's easier. Oh yeah, so now I just change drill here and then I drill it halfway here and 5 millimeters from that edge there. Yeah. Okay, now this will be now drilled all the way through here. It's a 6.5 millimeter drill. And I'm running this 300 revolutions per minute. And yeah, oh well, let's see. Feeding by hand. So here we go. Wow. There you are. Oh well, it seems to be all right. Yeah. Well. Now, this jig starts to be ready. Yeah, there is this hole. And now it didn't come through here, which is really good here inside. And now I just debur it and then I split it with a hacksaw from this point in the middle here. And then we can start doing the actual thing. Okay, well, now I'm making a slot here. It will be 5.4 millimeters wide and 30 millimeters deep, measured from the top surface. I already started a little bit. I just tried out how this cuts, and well, I can tell it cuts really nicely. So now, well, it's just to mill this. I'm like traditionally I have had no luck with slitting saws, but let's hope this one doesn't do any damage to me. Well, I'm using WD-40 as lubricant here, and let's go now. Yeah, it goes like into cheese, this one. But I know from experience that this may change in a second. So one should be really careful with this. Oh yeah. Now we need to have some lubrication there, I believe. Let's go. Well, that was the first slot. Yeah. But it's now 3 millimeters wide. So I need to make some offset to it, and yeah, seems like we need to vacuum clean this. So I did offset it to 1.2 millimeters that way. So now I will offset it to the opposite way, 1.2 millimeters. So I need to go back that much and then come back like this. Now it's on the other side. So this should be easier because it's now like oh well, let's see. This cannot jam, so to say. And yeah, it's cutting really nicely. This goes really like into butter. Let's take it all the way through. I think we left, yeah. Now it's done. Okay. That's it. That's the first slot. Oh, wow. I need to vacuum it and let's see. Okay, now, well, this one will be, the slot wide will be 8.4 millimeters, so I have to step over 2.7 millimeters to each direction. And man, this one is creating a lot of, well, mess. So I'm running this at the moment 100 RPM and trying to keep it lubricated with WD-40, and away we go. Back up a little bit. Well, and now we have here in the middle a little thing that should be taken away. Let's see, I roll this backwards. Doesn't rub at all actually, so this is all right. Okay. And now this center thing, well, it's very easy to remove. I just move this to the center. I have to take care of the backslash here. So, and now we go. Yep. There you are. That was the center. Oh. Let's see. Seems to be alright. Yeah. And now I just clean up the mess again. Okay, there you are. Well, I have two more to go. Okay, and the last ones will be a little bit different. This is now the other of the two last of these slots. It will be, well, seams 10.4 millimeters. And since our blade is 3 millimeters wide, it should be like 3.7 millimeters each direction. And I have already dialed it in here, so let's just do the first cut here. Oh, that blade is really. Oh yeah, that helps. Uh-huh. Okay. This behaves a little bit differently now for some reason. Let's take those pieces away. And okay. And now I need to get this away from here. Okay. Okay, and now it doesn't want to come out yet, but I put this screwdriver here and give it like that, and then it lifts off like that. Okay, it's properly clean, maybe. Okay, now it's in the bottom. It's already tight, so now just Tighten this here. That's the 10 millimeter one. And this really holds it so that it doesn't come off from there. Okay, now again 2.7 millimeters here. And now first the zero was here. So 1, 2, 3.7 is there. That's the correct place. And now just mill it. That's the last one. Hopefully this goes well. This one went quite far without binding. Okay, it's almost through. Well, flat bottom. And that was the last of this, and now I just debur those, and then we move to the next object. Okay, dialing in this workpiece here. Wow. Okay. Yeah. When I loosened the previous workpiece, I loosened these two jaws, so it should be reasonably concentric at the moment. But you have to dial it in. So I take it to that back surface there. Hopefully I can get it somewhere near. This is not easy to do because this dial indicator has a very limited range. Doesn't want to grip. Okay, now it is there, but let's tighten it a little bit more. Yeah, okay. Now, let's try this out. Oh wow. That's definitely a low spot. Or is it? Oh wow. I could even try to. Okay. So loosen this one, tighten that one. Loosen that one, tighten that one. Huh. So it's too much here. So let's see now. It's still like okay. Well, it's not on the. This is so. Okay. Maybe I can have the needle. Oh yeah, now it's better. Okay, let's see now. It's still wow. Like I think I need to that much. Then we have this Rockhold paste, which was really bad idea. Okay, a little bit better. Yeah, this we can do. So I should dial it in about on this point. So this is all right, almost all right already. So this one should go that way, not this way. Okay. Then I don't want to mark these workpieces, so I'm really gentle at this point. Okay, let's see now. That should be our point, so this one should be tightened, I believe. No. Okay, wrong direction. Okay. Which way is it? That way. Okay. Okay. I think it's inside 100s now, but now I need to tighten all of them a little bit. And try to keep it concentric. This isn't usually a bad job to do. Okay. Okay. There you are. Okay. Then just move this thing here on the top so that it's not on the way. And then I just drill some holes. That's the first. And there we go. 6 holes. This here is now the process of making holes for threading. So it will be 6 holes on this side in a circular, a bolt hole pattern. And they are, originally it would be 8 holes, but two holes are not done. So 3 holes other side and 3 holes the other side. So, and this one is now the second one I'm making here. Yeah. So, running this about 500 RPM, and well. And one thing about this, if you are running this in high speed, yeah, it warms up the bearings. Yeah, well, but that's expected. This old lady is not intended to run like that. So I will change the drill, and yeah, and I have 3 more to do this. So, I'm not going to punish you by showing all of them. Next step will be to thread those, so we will meet in the drill press. Okay, here we are at the drill press. Well, the next thing for these is to chamfer those, and I'm using this sort of a bit. This is very useful for hands-free freehand chamfering. You just need to be a little bit careful not to chamfer too much, because this is really sharp and can go pretty deep pretty fast. Okay. Yeah, and I'm using the rubber mat under here. As you can see, it really does the job quite fast. Yeah, next. Yeah, I'm using this rubber mat to... there are 2 functions of this. It prevents scratching, and then it also holds the workpiece really well. Yeah, and this is fast. Once you get the feeling on this, you can get it pretty consistent. Consistent enough. Yeah. I already did one, so this is the last one. Okay. yeah, there you are. Well, now the next step is to tap. Well, cut threads into those. So now, well, first I will align. This is a tap follower, like this. It flexes, and yeah. So I need to align it with those existing holes. There you are. And then I'm using this M5. This is, well, it's, I think, yeah, it's a Dormer M5 spiral flute tap. It's not a, it's a plug tap, it's not bottoming tap. So it leaves a few turns at the bottom unthreaded. And then, well, this one doesn't have a place for the tip of this. So I'm using this tool, which then has one suitable hole like that. And then I can put this here like that. And then just let's start tapping. I probably could have used my Tap-matic here, but well, setting this up would be, oh yeah. Okay, now we go. Yeah, this is spiral flute tap. So at start you don't need to break the chips, but then it starts to become tighter, so then it helps if you start breaking your chips. We are bottom, it's in the bottom now. And then I just go on doing this for all the remaining holes. Okay. Okay. And now, well, I have attached the workpiece here with a bolt, a nut, so that I don't, there is a, okay, that's it. Just need some cleanup, and then that one is ready. So let's take the next, see that there are no chips under. That is because I don't want to, because the chips would mark the surface quite easily. So now, this is just to hold it in place, so about there maybe. The place is quite irrelevant. Doesn't need to be like tightened like crazy. And then I just do, well, 3 more. This and 2 more. Okay, so This here is the setup for the last bit. This is just a ring like this, and the intention is to drill holes so that there will be a bolt which is squeezing this. It should be an M6 bolt. It will be threaded and there will be a recess. So I place this first here, like that, and after that, without tightening it, because it will lift it a little bit, I will now, well, yeah, here is a depth. I'm measuring, using this to measure my depth. Okay, and then I just place my end mill here. Hopefully it now goes there. Yeah, it did. I don't tighten it yet. Put it there so that I can slide it a little bit. Okay. Then I come here on the top of this workpiece like this. And then I draw it down like that. That is in 0. So now I know where this starts cutting. Okay. Well, none of this is really needs to be exact. Okay, now I can tighten this one. Which way is it? I might have lost it already. Let's do this again. That way. Yeah, it lifts it when I tighten it somewhat. Not a lot, but it does. Maybe 500s. No, not that much. Very little, actually. Okay, now that's there. And then, before I really tighten this, I put an additional support here. This one is here to prevent this workpiece from coming up from the vise. Really bad things can happen if this lifts up from the vise. So, oh, this is not straight. Well, it's straight enough. Let's see. Oh, well, it's not good. Not good at all, actually. Well, I need something under here. Let's see. This is some Russian steel. Okay. Now I'm pretty sure it will. I can put it level here. That's the intention here. Okay, now it's level. Because these clamps won't work very well if they are tilted. These. So it needs to be like there, I believe. I need to be careful enough not to go on the way here, because I need to mill here. So I take it a little bit back. I think there you are. Okay. Now I didn't tighten it a lot. Now I tighten this one, and then I tighten this one too. Yeah. Now the workpiece sits there quite securely. This is aligned, and I also have, before I did any of this, I also aligned the X and Y so that the X is actually at the edge of this workpiece and Y is at the back side. Now the first slot to mill is, well, the X direction seems to be 6.5 millimeters. Okay, so I have here a dial 6.5. I need my optimizers to see it. So that's now 6, yeah, 0.5. There. And then I lock the answer here. Yeah. Now X is set. And then we dial in Y direction, which is, let's see, there is the 0 and it's 6.5. How convenient. That's 0, 6.5. That's 6.5. There. Okay. We are ready to go, and the depth here will be 15 millimeters. This one can go, well, not backwards, but I want to have this on high gear. 400 revolutions per minute, and now this end mill is, maybe I should put some cover here so that it doesn't throw chips into this thing. Okay. Well, the end mill in this case must be such that it is also cutting in the center. If it's not, it will break if you plunge it into that material. So now, 15 millimeters. Let's go. And it's the Y. There you are. Oh wow. The next will be 18.5 millimeters. The Y direction. 18. Again. Oh man. 18. That's 18. There. And 0.5. There. That's the place. Should be. Okay. And now we just do the same. Oh, yeah. Switch to these. Okay, that was about that end mill. And now next step will be a 5 millimeter drill all the way through. Let's use some cutting oil here. Wow. There you are. Oh, that was something. Oh, oh man. Okay, next hole. That's probably the most. Oh, well, it didn't warm up the workpiece, so it cuts quite well. Oh, well, it's very nasty. So 6.5 millimeters. The previous 6.5. Yep. There we go. It's very dirty inside there. Man. Ooh. And now comes the last part before actually tapping this. We need to, well, why 5 millimeters? Yeah, it's the tapping size for M6. And now we need to make holes that the M6 bolt can go through. And these need to be, let's see now. Yeah. No, not with this one, but that one. Okay. And these are a lot easier to do. So it will be like 25 minus 15. I think that's 10. Yeah. And of course I have placed it so that because the drill is like there is an angle, so now it's leaning on the very rim. So 10 millimeters down here. Not with that speed, so we can use. Oh, man, we can use the same speed here. So 10 millimeters. Very easy if you compare this one to the previous. That's 9. Yeah. And now it's 10. Yeah. And the other hole as well. And then the same dimensions apply, so I can go directly from here. Okay, that's ready. Well, next step will be, for this one, will be making threads into that one. So now I just put there the next workpiece and do this operation 3 more times. I have 4 of these pieces. I clean up and do the same thing again. Okay? Okay, and now we have 4 of these. And here is one patient now. We should make this side M6 thread. There is a 6mm hole halfway through, and now it shouldn't make threads on this, but the document there was stated that this hole should be 6mm. That's not the clearance hole for M6. Actually, the clearance hole is I think 6.5, and therefore it will be scratching a little bit that surface there. So, and this here is a gun tab. It pushes all the chips down into the hole, and since this is a through hole, well, yeah, and furthermore, this is really easy now because I can just let the 6mm hole guide me through. Now it started cutting. You can feel it. And then we just push it all the way through. The gun tap is really nice to tap because if you have a through hole, it never ever binds. I have not seen that to happen. So this is one of the most secure. Oh, now it binds. What did I say? It never ever binds. And now it actually binds. Oh yeah, we are through. But I turn it. Why does it bind so hard? Maybe my tab isn't sharp. Let me change this. This might be dull. Man. Yeah. As you can see, it makes threads to the 6mm hole as well. We have a brand new one. That should do it. I will go through it like one more time and see what happens here. I think it's, yeah, it is. Well, I have to look. Ah, it's all the way through. Yeah. Well, you should have a similar flat on the other side as well. That's the case here, actually. And when I put this into here, those damn things, I use this pin. This is a 5mm pin to put it about straight. Just eyeballing. And now, let's see whether this stuff makes any difference. It should. Now we have some stuff in there, and let's go with the first one. That's the 6mm portion, and now start it. This is a little bit easier now, actually. Well, it's very relative, this easiness. Yeah. Oh, no. This is really a lot easier now. The end, especially the end, is easier. Okay, now we come back. Okay. Oh man, okay. Let's see how it looks. Well, the threads look like done. Well, I need to deburr this. There is a horrific burr. Oh man. Well, okay, 2 done. 2 more to go. And after that I'm ready. Well, that's it then. Some parts, if you wonder, what are these for? Well, I really don't know. I don't have a faintest idea what these parts are for. It's just a fellow Finnish machinist who wanted these operations to be done for these parts. Well, this about concludes this episode of Finno-Ugric Machining. And, in the next episode, again, I really don't know what we will do. Maybe the crafting press, it needs a wooden pedestal. Maybe, woodworking. Who knows? Anyway, till next time, bye!